Right, this will be the last one on Trigo. We will finish everything today. We are going to do, look here, we're going to do exercise 11.6, question 5, 10, 11, 13, 15. And then later I'll go through these two pop quiz answers. Now let's start with question 5 of 11.6 in your textbook. Now you read the question first and then you try. Okay, the depth H meter of the water in a pot T hours after noon. That means after 12. This means after 12 p.m. Okay, it's given by this. Alright. Okay, now you may want to just roughly do a sketch. So what this means is that this is a real life problem. And H, okay, is here. T hours, right? T, the time is here. Time is in hours. And you must take note. The time, right, starts after 12 noon. That means this is actually 12 noon, but we don't put 12 noon here, we put 0. That means this is, you think about it, that means when I first start timing, right, what is the time on my watch? It is 12 noon. Okay, so let's say later I have, example, 1. What time is this? Okay, this means 1 hour after you have started, alright? But on your watch, it means 1300 hours, which means 1 p.m. Okay, so you must understand this, otherwise you can't do the later part of the question. Now, remember how to sketch this? We do the center line first, right? So you do the center line, okay, and that will be 5. And then 1.2 up, right? So this is 6.2. This is 3.8. And then this is a cosine graph. So wait. Quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. Okay, so this is what the graph looks like. And in part 1, alright, they say that a boat with a draught of 4.2 meters. Now, what does this draught means? It means that, when you, let's say this is the water level, okay, this is air, this is water, okay, so maybe let's say this is the base, okay, the sea base. Alright. Now when I put a ship or a boat or whatever, okay, onto the water, I mean into the sea, or into the ocean or whatever, right? The distance between this water level, okay, before the water meets the surface here, okay, the air surface here, and the lowest point of the, let's say this is a boat, this is called the draught. Okay, that means this distance here is 4.2. Okay, that means in other words, right, this word means the distance between the base of the boat and the water level, okay, the top water level here at the water surface, before the boat can float. Meaning to say, I give you a counter example. If let's say now there's no water there's no water, then this is the sea base, the base of the sea. I fill water up here, okay, it won't float. Let's say I fill 1 meter, won't float, 2 meter, won't float, 3 meter. Only when I fill up to 4.2, only when this is 4.2, right? That means the distance between the lowest part of the boat to the water level here before it meets the air. Only, that means it takes 4.2 meters of water in order for this boat to float. So this is the meaning of this draught. Okay, I hope you understand. Okay, so I ask you what is the minimum amount of water for this to float? Must be 4.2, right? So if it's 5, will it float? Of course it will float lah. But if it's 4 meters, will it float? No, it won't float. Okay, so they are asking you can the boat leave the port safely 4 hours later? 4 hours later means what? 4 hours later mean at first is 0 hours, right? From 12 noon. So 1, 2, 3, 4. That means your T must be equals to 4. Alright? Okay, so let me show you the working here. This is what we are given. I think you understand this part, right? This is exactly this. Then when T equals to 4, right? 4 hours later, I sub in, I sub in 4, see? Just sub in only. Then you remember, you must be in the radian mode. Why? Because this is in radians. The T equals 4, right? Normally for this real life application, we don't use degrees one, okay? Is in radians. Then you will say, but this is in hours, right? Yeah, but when we sub in, it's actually just a unit, 4 units, okay? So you just use the radian mode and then you calculate, you'll get 4.49. Now what does this mean? It means that when I look at the picture here, you can't see, is it? Wait, okay, can see already, right? Okay, when the time is equals to 4, I mean after 4 hours that means actually it's 4 o'clock, right? Because 4 hours plus 12 noon is 4 o'clock. The water level, see the depth of the water, the depth of the water is 4.49. Now, ladies and gentlemen, 4.49 meter. 4.49 meter, is it enough water for this boat to float? That's what it means, Yes, there must be enough water. 4.49 is more than 4.2, right? So there is enough water for the boat to float up and then leave the port safely, Okay, if not, if there isn't enough water, right, the boat cannot float, the boat would maybe topple to one side. Okay, so this is a real life question. So since the drop of this is less than, okay, or you can say greater than 4.2. Okay, therefore you can leave the port safely. Okay, okay, now I hope you understand. So this particular topic, this section of 11.6, right, is on application of your later you will see maybe got some R formula or whatever, okay, but it's application question. Now suppose the boat had left the port safely, okay, that means leave the port already after 4 p.m. already. Suggest a range of time in hours and minutes. So your answer later must have hours and minutes for the boat to re-enter the port safely in the next 18 hours. That means they are trying to tell you, right, to find the time whereby the height of the water is at least 4.2, because only when it's 4.2 then it can go in and out of the port safely, right? Correct or not? So it must be like more than 4.2 lah. Okay, so the answer is here. For the boat to re-enter, right, the height must be this. So we go and equate this height of the water. You see, this actually came from here. So don't be scared. This thing came from here, and then we let it be equals to 4.2. Okay, and then you minus 5 both sides, you get this. Divide by 1.2 both sides, you get this. I think this part you understand. Okay, let me erase. And then you find the reference angle. Okay, no need to write this. You straight away write this. Now remember, reference angle, we don't take the minus, right? We only take this. And then remember your add mat. So already this is E. Okay. Then the domain and everything. Okay, you see this fella, right? The cosine is negative. So you want cosine to be negative. So it must be here or here. Not here, not here. Because here and here cosine positive, you see. Okay. So after that, okay, no need to write this. You draw the ASTC quadrant can already. Alright. Now, this is your alpha. And notice that alpha I put to 5SF, right? Don't use the rounded off answer. Okay, so it must be in the second quadrant or in the third quadrant. Okay? You will notice that actually you can go one more round. How come like that? Where is that thing? Wait here in the next 18 hours, right? So you are able to satisfy this, this. All these fall within here. Okay, so when I convert, okay, the 4 point something don't do anything to it but you convert this to this is this one so I convert already, right? Okay. Oh, I find that okay, I continue here. Where's that diagram? Okay, it's up there. Okay, never mind, I redraw here. Remember just now I drew a diagram. It's actually on top. Then quarter of an A, quarter of an A, quarter. I drew 5, right? Then quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg, right? Okay. So just now we already set it to 4.2, right? Okay, 4.2. So where is 4.2? 4.2 would be somewhere here. Correct. So this value, right, is your 4 point here 4.57 something. And then this next value, right, is your 7 point something. This part you got to understand. And then the last part, right, is your 17 point something. Where will it be? 17 point something would be another quarter of an egg already. Quarter of an egg. Oh, okay. So it's here, right? So this would be 17.077. Now, what does all this mean? All these are in hours. Okay? That means this. Okay, this is 12 noon. This is 0. But actually this represents 12 noon. So don't you agree that because the graph goes like that, right? The water level will be above 4.2 between here to here. Correct or not? Between here to here. Okay, so this is the duration and here is the 70 point something, but from here to here you add 5 hours plus. Oh sorry, 10, about close to 10. So when you calculate, right, you'll be these two answers. Okay, this is your 7.55 p.m. and this one, alright, is your 5:05 a.m. the next day. Alright, okay, so that's all. Okay, now next one. A mass attached to a spring oscillate up and down position B. The change in position is given by this. So what it means is that there is a spring, right? There's a spring and then this mass attached to the spring go up and down. Okay, this is point B. Then you go up, go down, go up, go down. This is what it means. Okay, then the change in position will, okay, I draw for you That means this, let's say, is the mass, right? Okay, it is attached to a spring. Let's say like that. Okay, then it oscillates up and down its rest position B. Okay, so let's say this is B. You go up, go down, go up, go down, go up, go down, go. So don't you agree this is like a sine curve? Huh? So that's why we can model this question using a sine curve. Okay? A and W here, A and W, they are just numbers. Okay, and the furthest distance that the mass can reach is 20 mm from B. B is here, right? So they are trying to tell you, oh, the maximum is 20 mm, and then the minimum is 20 mm away from B lah. So don't you agree that the A has to be the amplitude value, which is 20 lor? Finish. Okay, okay, so that is why 20 and no need to convert to meter or whatever, because they say all these are measured in mm. Okay, then now given that the mass takes 0.25 seconds to complete one cycle, so what does this mean? It means that the period is this, and we know period is 2 pi over the number that is in front of the t here, right, or the x or whatever the variable is here. Okay, so you go and make w the subject, you will get 8 pi. Leave it as exact form, 8 pi, finish already. Alright, now wait. Okay, find the exact value of t when the mass first returns to B. Now when it goes back to B, right, what can you say about the y? Because y is the change in position with respect to B. That means you measure from B. That means your y here, right, is the 0. You look at what I'm doing here. Take this as the y-axis, and this rest position. That means when it's not going up and down, right, or it's at rest, it's resting, not moving, right, the y is actually at 0. Okay, so you set y equals 0. Okay, put it where? Put it here. Okay, and you already know your this, you already know your this is your A, this is your W. You all know all this already, right? Then you go and find the value of t lor. Finish already. Okay, so that's all for this particular question. Okay, now the next one. The next one okay. Projectile motion. An artillery shell is fired outwards at an angle of this as shown. That means you shoot like a bomb like that, and then it dropped here. Okay, you shoot at this angle theta. Assume that the horizontal distance d meters, this is the horizontal distance that it traveled, can be modeled by this, where v meter per second is the initial speed. Okay, so this v is the initial speed. This theta is this theta, okay? Then the rest are all numbers. It's given that the initial speed is 770. A soldier feels that if the shell is fired at an angle of 50, it will achieve the maximum horizontal distance traveled. Sketch the graph. So to sketch this graph, very simple, right? Because this graph for 0 to 2 pi, if you look at this, your period will be 2 pi over the number in front of the theta, right? So it's pi, right? That means one full cycle. Okay, I just do a sketch here. One full cycle is, okay, quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg, right? With pi. So halfway is pi over 2. So they want you to sketch from 0 to pi over 2, right? Then you follow the instructions. That's why the curve is just like that. Okay, with this as pi over 2, this as theta, this is d, and then label the graph, and the highest point when see when theta equals to pi over 2, if we sine pi, that's 1, right? 1, that's why it is 1 times v square over 9.81. That's why this is the value lor. And actually you must label this pi over 4, half of this one. Okay, half of this is pi over 4. Alright? Okay, so they ask you to explain. So you need to draw the graph because it says sketch the graph and use it to explain why the soldier is wrong. So you say that from the graph, the maximum horizontal distance occur. You see this is the maximum, right? And it occurs at where? Pi over 4, what? So that is the answer lah. Okay, okay, so that is all. Okay, the pi over 4, right? It's actually 45 lah. And it's not 50. So this is wrong. Okay, now we go next one. Now assume that the up-down oscillation, this one is like something like just now that question, right? Okay, there is something when it's not moving, it's at this position. Then when you start to move, right, maybe like a spring like that, then you go up, go down, go up, go down. So it's like a sine and cosine graph like that. Okay, so if you look at this question, they have sine and they also have cosine. So express, now we talk about the R formula already. Okay, use it to explain whether the mass can reach a distance of this. So we let this be this. This one no need to do. Then you find this. Okay, I think this one you should be very familiar. Okay, then how to get this alpha is actually the second one over the first one. So actually down here, right, before this step, it's actually 8 over 6. Then simplest form is 4 over 3. Then you inverse tangent it, you will get this. Okay, so this is your R formula. Alright, now you are supposed to use this R formula to explain whether the mass can reach a distance of this. So remember, this one they're actually testing you on whether you know that the maximum for this is 1, minimum is -1. Okay, so you see, sine can never be more than 1, right? Sine of anything can never be more than 1. That means when you times 10, this one will be always less than or equals to 10, right? So the maximum value of this is 10. So it's not possible, because they want 15, but the maximum that it can reach is 10 mm only, so cannot make it. Okay, so that's all. Now find the time at which the mass first reaches the maximum distance from x. Now maximum distance from x means what? The thing, as I said just now, right, is moving up and down from this x. Okay, so what are they asking you? They're asking you, because maximum, they're asking you when you will reach the maximum here. Okay, so isn't maximum 1? So you do here, wait, screw up, 1, and then you think, then you go find the answer. That's all. Okay, so that's it. Okay, now how much time does it, where's my part 3? Okay, here. How much time does it take to make one full oscillation? Now, one full oscillation or one oscillation, isn't that period? Isn't this period? Okay, so period is, as we mentioned, 2 pi over the number in front of the unknown t. So it's 2 pi over 5. Finish already. Okay, next, all these are testing you on concept. Okay, now next, solve this. Now we have already expressed this here. Where is it? Here, right? This is this. We have already expressed this in terms of this, which is this. So you just quickly replace it with here. Replace this with this. Hope you understand, because this, which is this, is actually this. We converted it already just now. Okay? Then because using AddMath, it's in the sine form already, then you just find the reference angle, the alpha. Okay, then you use your ASTC, then you ding ding dong dong, then you can get the answer already. Okay? So this is the answer. Explain why there are two values of t and what they represent. So the two values represent the time at which it is 5 mm, okay, from the rest point x, meaning, here I draw for you, if this is x, this is the rest point, right? You will go up, okay, then you will come down, then you will go up, you will come down, go up, so you oscillate like that, right? Like a pendulum, like that, okay. So there are two timings. Why? Because one of them is maybe is here when t equals 0.338 here, then it's here, and it is 5 mm away. Then another 5 mm is when it's below, you see. Then that will be when t equals to 1.18. So that's all. Okay? Yeah, so that's how you can explain. Now for the last question in this workbook, let me just go through the last one. Okay, the gravitational potential energy that an object has due to its can be calculated. Okay, so don't be too scared by all the words. I know it's very wordy, but the main thing you need to know is this formula. M is the mass, this one is the gravitational potential, and this is the height. Mass, gravitational field strength, and then the height, mgh. Okay, and they tell you that the gravitational field strength is approximately 10. Later you can use it. You see, we use it here. The gravitational field strength, gravitational potential energy of a ride in circular motion t second after loading start is given by this. This is the important trigo equation that you need to know. Now, given that the mass is 1000, and that the initial loading is 3 meters from the ground, show that A equals to this. So this is the A that they're referring to, okay? You need to show that it's this. But how to show? The initial loading is 3 meters from the ground. What does this initial loading mean? And given that the mass is 1000, so how do you do this question? Now this is your H. Okay, so you must be able to identify this. H is the height of the object. There, 3 meters above the ground. Isn't that the height? All right. So you know your M, which is here. Then I told you already, You know your G, which is 10. This is your G. And then you know your H, which is 3. Then you can find your E already. Why must find E? Because there's an E here. Alright. So all this information will help you find E. After you have found E, you sub E and okay, wait. Show that A equals to this one, right? T equals 0, then the E is this. So you sub in and then you can find the T equals 0. Sub in, you can find your A already. Finish. Okay? Now explain why this model suggests that the maximum gravitational potential energy possessed by the ride is 230. Okay? So you look at the equation. E is equals to 100. Okay, so when will you have maximum Okay, I plug in all the values first. 100, 1 minus cos kt. K do we know? We don't know k. Okay, kt. The a we know already, right? Plus 30. Don't you agree that in order to get maximum e, for this number to be very, very, very big, right? In order for this number to be very, very big, don't you agree that my this must be minus 1? So that 1 minus 1 is 2. So I will get E maximum equals to 100. This 1 minus 1 is 2, right? Plus 30. Then I can get 230 lor. Kilojoules. Okay, yeah, shown here, I think. Yeah, shown here. Alright, so that's all. Okay, I'm just explaining what's going on here. Okay, now, the next part. Now the ride takes 6 seconds to travel from one peak to another. Peak means the highest point. Okay, so you take a look. This whole question, right? They're trying to ask you, oh, the ride go up, go down, go up, go down, right? Between two peaks is 6 seconds. Meaning, let's say like that. Okay, or I try and draw this for you. Okay, see how important a graph is. So when it say 30, okay, 30, then it's 1 minus cos, right? So instead of here, you'll be like that. Oh, sorry, you'll go down. Go down some more. Like that, right? And go top, and go top, and go down, like that. Okay, so there'll be another peak, right? So they're saying that between here to here, these are the two peaks. This peak, the highest point lah. Okay? They want you to show that k equals to k over 3. Alright, so how do we do that? Okay, because the period, one peak to another peak. Okay, wait. I'll draw back for you. Don't you agree that here, quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg, 4 quarters of an egg, right? So peak to peak is actually one period. That means it takes 6 seconds to make one full cycle. You see that? It takes 6 seconds to make one full cycle. And we see that this k is the number in front of the unknown t, right? Okay, so wait. So using this formula, you can find your k already. Okay? Now find the gravitational potential energy 8 seconds after the ride starts. Now what does this mean? It means that they want the GPE, okay, which is here, okay, 8 seconds after that. So all you need to do is to sub in 8, and then you can find the answer already. Finish. Okay, that's all. Finish already. Now the last part, you maybe need to think a little bit. If the ride lasts for 60 seconds, the whole ride lasts for 60 seconds, find the duration of time in which the ride possesses more than 80 kilojoules of energy. Okay, so a few things to consider here. We want this, okay, to be equals to we equate it to 80, and then we will know when you'll be above 80 from what duration to what duration. So firstly, you let this E, this is your E from here, don't be confused, okay? We now know the K, we now know the A, that's why we put it in, and then we equate it to this. So now you are using AddMath to solve. Okay, so make this cosine of something equals to a number, that's your E. Then after that, find your alpha. Use your ASTC to find out which quadrant. And then because cosine is positive, right? So when I draw here, Cosine positive, you want here and here. There, that's what they mean here. Alright, so you will have these answers 1 or 5. That means let's say this is your 80, right? This is your energy, you want it to be more than that, right? So it will boom, boom, and this value here is 1 second. This value here is 5 seconds. So the duration for it to be above having 80 kilojoules will be 4 seconds. But this is only for this period of 6 seconds. Okay, we want for 60 seconds, so you must times 4 to this, times 10 to this. Because there are 10 complete cycles in this 60 seconds. So the answer is 40. Okay? Alright, we'll go now to the pop quizzes. Then that will be the end of this whole A Maths Trigo. Alright? Okay, this is a real O-level question, 2012, paper 2, question 9. Okay, this line and this line are not given to you. Okay, you refer to your own worksheet. Only these are given to you. Okay, this is just our rough working. Alright, now in the diagram, ABC is a structure consisting of AB. This is a rod, 10 cm, and it's attached to B. And then BC here is 24, so that ABC is 90 degrees. Okay? Small rings at A and B, here, there's a ring here, allows A to move along. That means A can move, This A can move. That means this rod can move one. Can move like that. Okay? And then this also can move. Of course, this can move here also lah. Okay? The horizontal here is L. Horizontal distance of C from the vertical line OY. So they are actually saying that this is your L. Okay, clear? Okay, then they ask you to explain clearly why L equals to this. So how do I do this question? Don't you agree this L, right? This L is this of this triangle plus this of this triangle. Okay? And using Tuakaso, this is 10 sine theta. Okay, so I think this part you understand, right? The BC prime is here. And then this, okay, if this is theta, right, this must be 90 minus theta, right? Okay? And using angles on a straight line, this is 90 minus theta, this is 90, this must be theta. Okay? Got it? That means your BC prime must be using Tuakaso, this one. So you have shown already. Finish. Okay? Okay, now next one. Express this in the form of this. Okay, this one very easy lah. Okay, I just want to highlight one thing. Where is it? You see, now here sine comes first, right? But because they want cosine, I actually have to rewrite this cosine first. Alright? Then you can you can use tangent inverse of this over this. This one is a shortcut. You can do it by the side here. You can say R equals to this. Then alpha equals to tangent inverse. Must be the second one over the first one. Okay? Then you'll get this ready. That's all. Okay, find the greatest possible value of L. Now, greatest possible value of L, you see here, is when this fella is 1, right? So it must be 26. And when does it happen? What must theta be? So you set this to 1. and then you can find the answer already. Very simple one, huh? Okay, and find the value of theta for which L equals to